Show. Review notes. Please write that as your title rather than just staring up here like you can't read. Review notes. Go. Write that down. Write. Come on. Spring, I said right.
I wrote it.
No, you did. You lied. Don't dare just fake it. Try to cover it up. Spring, what are we going to do with you? Okay. So first thing. Yeah, Motley Crew. First thing we talked about was scale factors. Okay, so we looked at that the very first day. With the scale factors, what we're looking at is this formula in the green box. Ooh la la, so pretty. You take your new dimension, you divide it by your original dimension. Yes, you will need to use a ruler. Or I'll give you the numbers. But you got to keep in mind what's the original. So I'll say something like from A to B. That means A is the start, it's the original, B is the new dimension. Okay? So once we did that division, so we write it as a fraction, we do a division. If we get a number that's less than 1, that's a reduction. So those numbers would be like 0.25 or 3/4. Usually we did the division and went to a decimal. And then, Sean's favorite color, if we have a number that's greater than 1, that means it was enlarged. Okay. So 1.25, 1.5, 2.7, anything that's larger than 1. Or a fraction, like 7/3. Okay, that's an improper fraction. If you work that out, it would be a decimal that's greater than 1. And remember that tricky one in the quiz which you all fell for, hook, line, and sinker? If it's equal to 1, then it's neither. Okay, you never know. Might put it on a test. Might not, but I might. Okay? So keep in mind 2 things I just discussed already. What's the original? What's the new? The original is the starting spot. Keep in mind, if I don't give you measurements, you will have to measure with that new device that was just invented called a
ruler. Good.
Okay. You guys have heard about that device. Perfect. Okay. All sarcasm aside, is there any questions about this? It's kind of the first day. Good. So we also talked about reducing and enlarging images, and you have to do that with the arrow diagram. So one way was when you use the same size grid, then you change the number of squares if the grid's the same size. Then on the quiz, you have to flip it over and you have to change the size of the grid. Usually when you did that, you matched up your scale factor, so you'd keep the same number of squares. The squares just happen to be larger. Okay. You can write fast, or did you not write it down? Sorry, Mr. Parker. There you go. Good. Then we looked at scales. So for scales, we talked about the diagram value. With the scales, we saw that we had to make one of the numbers out of 1. So our lowest number, we divide by itself. So either the diagram number was 1 or the actual number was 1. The units must be the same, so meters to meters or centimeters to meters. And usually what we did, if we had a decimal, you saw this on one of your assignments, if you had a decimal like 1 to 6.5, you'd multiply to get rid of the decimal. Okay? It's not very common, but I think today in your review homework that happens one more time. Okay, so just be aware of that. That's what they did. Now, like I said, I've seen lots of times where they have decimals, but I think pure math teachers would say no decimals. Good. So moving on then, after we had the same units, we went for the map. The map is a great example. Just finished covering it again at the grade 10s because it comes up. So our map is centimeters to centimeters, and the map is huge, right? 65 million centimeters. Okay. So we got to turn that into something workable. We got to turn that into kilometers. So what we do is we divide by 100 to get to meters. which means you cross off 2 zeros. Then for meters to kilometers, we divide by 1,000. So we end up with 650 kilometers. 650 kilometers. So the scale can be turned into 1 to 650 kilometers. All right, so you got to do some work on the side and show me the work, folks. If you write it down, you'll get it right. If you don't write it down, seriously, out of 5 people that write it down, don't write it down. 1 maybe gets it correct. Okay. So you go and take your map and measure it to be 5.5 centimeters. You measure that. What you need to do then is set up your ratio. Okay. So D over A. So once we have the scale factor, you just multiply the bottom by the scale factor to get the new measurement. Any questions? Okay, going on. Here's your answer, 3,575 kilometers in real life distance. Okay. Okay, then we talked about similar triangles and similar figures. So with similar triangles, we looked at that yesterday and the day before, similar figures. Same angles, boom, triangles are similar. Or check the ratios of the sides to make sure they're in equal ratios. Okay. So check the old notes for that. We're not going to go over that. We just covered it yesterday. It should be rather